In number 1, we're asked to show that these 4 points all lie in the same plane. One of the basic definitions of planes is that any 3 points would define it. So already we can pick any 3 points we want to, for example A, B, and C, and all 3 of them have to lie in the same plane. The real question is, does point D also lie in that same plane? So we're going to use A, B, and C to make a equation of a plane. To do that, we need a point and 2 directions. So direction 1, we'll call it AB. Do our vector subtraction, we'll get 6, -7, and -5, B minus A. And if we do the same thing and pick a different one, let's call it AC, just for fun. You can also do BC, nothing wrong with that, or CA, or anything else. We'll get 0, -1, and 4 minus 6 is -2. So we've got ourselves 2 directions. If we want to check if a point lies on a line, one of the easy forms to do that in is our Cartesian form. So it helps if we get our normal, which is made up of AB cross AC. So vertical direction, -7, -5, 6, -7, and -1, -2, 0, -1. And cross multiplying, -7 times -2 is 14, minus 5, 0 minus -12, and -6 minus 0 gives us a normal of 9, 12, and -6. Okay, now you can use those numbers if you want to, or if you want to just make it a little bit easier to work with, you could reduce them, divide them all by 3, so 3, 4, -2. That's what I did for my answers. Okay, so we're making ourselves a Cartesian equation, so 3x plus 4y minus 2z plus some value d equals 0. To figure the d, we have to use one of the points that we already used to figure out the d value. So A, B, or C, your choice. I'm going to use A, so 1, 2, 6 for x, y, z. So 1 for x, 2 for y, and 6 for z. And then we're going to solve this. So we'll get 3 plus 8 minus 12, which is -1. So the d is 1. So our Cartesian equation of this plane, 3x, 4y, minus 2z, plus 1 equals 0. That's the plane that points A, B, and C lie on. The only thing we need to check now, does point D also lie on that plane? So -3, 5, and 6 can go in for your x. So -3 for the x, 5 for the y, and 6 for the z. And we're going to check does it come out to 0 or not. So we'll get -9 plus 20 minus 12 plus 1, which gives us 0 equals 0. So yes, all points lie on the plane. Now you could have done it in any other order. You could have made a plane equation using A, B, and D, or A, C, and D, or B, C, and D, and just check the 4th point. It's going to work no matter what. Okay, for part B, determine the distance from the origin to the plane you found in A. Okay, so distance from a point to a plane. So in part B here, to move it down a little bit, we know that the distance between a point and a plane can be found using our scalar equation, the coefficients in particular. So 3 times, remember our point here is 0, 0, 0, okay, that's the origin. 3 times the x-coordinate, plus 4 times the y-coordinate, minus 2 times the z-coordinate, plus our d value over the magnitude of our normal. So we're going to end up with on top 1, on the bottom the square root of 9 plus 16 plus 4 would be root 29. You can leave it that form, or you can change it into decimals if you want. And the last one, part C, determine the point of intersection of the plane we found in A and the line we're given here. Okay, so just going to rewrite it for just a second here. So, C. We have this symmetric equation. It helps us to work in parametric form. So x equals 2 plus 3t. Remember, change your signs on your point, and negative 1 minus 2t for y. Oops, t. And z will be 3. And z's always 3. Okay, so I've got parametric equations, and we have this Cartesian equation we found in part A. And so we're going to bring it down here. 3x plus 4y minus 2z, and it's a plus 1, yep. Plus 1 equals 0. So how do I know if this line lies on this plane, or the point of intersection of this plane and this line? Well, if we put in our x value as 2 plus 3t, and our y value, negative 1 minus 2t, and our z value, which is just the number 3, we're going to be able to solve for t, the parameter. If we know the parameter, we can then go back and use our parametric equations to find points. So we'll expand. And we'll collect. So we'll get 9t minus 8t is just t. The 6's cancel each other out. Just to show that, we get negative 6 plus 6 plus 4 minus 1. Or in other words, t is 3. So if t is 3, we can now figure out the point where these two things intersect. X is 2 plus 3t, which is 3 plus 3. So x is 11. Y is negative 1 minus 2 times t, but we said t was 3. And there, sorry guys. Fix that. 2, which is negative 7. And z, no matter what, is 3. So the POI of the line in the plane is the point 11, negative 7, and 3.